All right, good afternoon, everyone. We still have a few people joining in. We have a few phone listeners as well. I hope that you're able to get it up on your computer as well so you can check out our slides, but thank you for joining us anyways. Still a few more floating in, it looks like, so we'll just give it a minute. All right, that looks good. So hello and welcome to Jamesway's Webinar Wednesdays. Thank you for joining us this week at our special time. We had to accommodate the exam schedule at the University of Guelph, so I hope those students did well on their microbiology exams this morning. For everyone who is new, and I think I do see a few new names there, welcome to you. Your control panel is in the upper left corner of your screen. There is a raised hand button there. There is an audio and video settings button you can use if you're having any troubles. There's a Q&A button. Please use that panel to send any questions to myself and Dr. Warriner. There's also chat. You can use that to chat either directly to myself and our moderator, Krista, or you can also chat amongst yourselves with the other members on the webinar today. So we have a special edition and topic this week. We're going to be going over the aspects of sanitation. And to join us, I've asked one of my old professors, Dr. Keith Warriner, to join us. He started out his microbiological career first with his undergraduate at the University College of Wales, Aberystwyth. There you go. And then also Nottingham University at Manchester as well. And then he, about 16 years ago, joined the University of Guelph in their food science department. For any of our listeners from Ontario in particular, you may recognize Dr. Warriner from certain appearances on shows such as Marketplace. And so we're really pleased to have you here today.
No, thanks for inviting. It's not very often I get invited by my old students. I think they see enough of me at the university. But no, it's a good opportunity because reality is I've never actually been in a hatchery. And you know, when I come from sanitation, I come from it from meat processing, fresh produce processing. But after saying all that, I think where we get advances and where we get new insights is when we come from different areas and different fields. So some of this is going to be applied to kind of the fresh produce and meat industry, but I'm hoping that it's going to be useful nevertheless. So to actually start with the presentation, and what I'm going to actually do is go through what the importance of sanitation, which I think we all sort of appreciate, given the fact that when we do get issues, be it foodborne illness outbreaks, be it outbreaks of disease in sort of animal production facilities, we always can trace it back to poor sanitation, and that's where it's vital to get right. And it's very interesting that all the plants I go to, there's always something wrong, and not because the people aren't diligent enough, but I think with sanitation, it's one of those things where you do it day to day, so you become blind of all those little shortcuts people have and things like that. So without much more ado, I think we can start, and hopefully you'll find it informative.
All right.
All right, so that's always a bad start.
Oh, sorry, that's me. There you go, that should work now.
Already, you see.
Yeah.
She's getting her own back. I knew she was a better grade. Okay, so what I'm going to be doing is I'm going to be talking about the importance of sanitation, which I think we all understand, but it's good to go over it again. And the key thing about sanitation, which very often people miss, and I can tell you a few companies I work for right now where I'm developing sanitation plans for them, is the documentation. So documentation always becomes a sort of exercise for people in terms of, well, we have to do it, we don't know why we do it, and things like that. But documentation saves you in a lot of respects. It saves you from when things go wrong, at least you can show your due diligence, but it's also a very good training tool. And when you get high staff turnovers, like we do in the food industry, it gives a very good training tool as well to keep continuation. And we talk about SOPs and also about the 6 steps to sanitation. And then we talk about the monitoring and verification and some kind of advances that's been going on in the industry, which you might find interesting. So the reality is that we all know why sanitation is important at hatcheries. Certainly within the first 7 days of chick coming into being, the mortality rate can really shoot up if you've got poor sanitation there. And as we'll talk about, the source of contamination can be various, from the raw materials coming in or the eggs coming in, right through to endemic populations due to poor sanitary design. And the ones of interest, obviously, are Aspergillus, that's a mold, and E. coli staph, and also Pseudomonas in terms of conjunctivitis. And it's going to be important to remember these because when we talk about sanitation monitoring, these become much more relevant and much more useful. So as I mentioned to you, it's not only bacterial and micro and mold, it's parasites and also viruses that are a key thing. So when you get outbreaks, you definitely are in a bad situation. You've got to try and correct it as soon as you can. And having a good sanitation plan in place certainly helps you to do that. So typically what you've got to do in any sanitation first is find the source of the pathogens of interest. It's no good just thinking it's an enclosed bubble that nothing can get into. We've got multiple sources. And so really, as I'll talk about at length and repeatedly, the key to sanitation is prevention. It's not having the issue in the first place. Sanitation is like a Band-Aid. It can kind of hide certain things, but not the underlying cause. So when we think about salmonella, for example, obviously in the poultry industry, we've got a very good surveillance program, seek and destroy and enteristis screening. For things like eggs, though, with staphylococcus, it's less sort of advanced. And so you can get contamination coming there. And obviously with molds like Aspergillus, they can come in from the air and be distributed and make niches in the facility, giving long-term problems, especially if you've got high humidity and temperature, which is frequently the case. So as I was mentioning, the key to sanitation is not to have a problem in the first place, and that's really controlling the source of contamination coming into the facility, which obviously we know as biosecurity. So eggs are rated as the highest source of contamination, but obviously air and water and people. The reason why I probably haven't been to a hatchery is that they wouldn't let me in for the simple reason you've got to restrict all kinds of movement. If they don't need to be in there, why should they be in there? It's just another source of contamination coming in, as is obviously feed, and pest control is vital as well. So before you do sanitation, you've got to really identify where the sources are and try to restrict them to start with. So the key to sanitation, it's not a sort of hidden secret, is that, and I've seen facilities do this, they think they can have poor facilities, implement a sanitation program using the most expensive sanitizer, and it fixes things. It doesn't. It's basically a Band-Aid. So what you're going to do is prevent. And the other sort of situation I see in industry a lot is the failure to remove soils. So when we're at home cleaning in the kitchen, obviously we don't care too much about a sanitation program. We just get the dish rag that's been on the sink for a few weeks, and then we'll just try and wipe the surface down. But the reality is, in industry, it's a bit more technical than that, and you have to remove organics. So when we saw soils, because they'll neutralize sanitizers, and they'll interfere, and they'll basically form biofilms. So that's key. Now, another sort of fault I see in the industry, and when I say the industry, I mean the food industry in general, is this obsession with high-pressure hoses. The higher the pressure, the better it is, but they produce aerosols. And I was at a facility just last week where they were complaining about listeria in their cold stores and in their sort of preparation rooms. And they were trying to figure out that it was the sort of cooling fans that were responsible, but it wasn't. They were basically blasting out the drains and it was releasing listeria into the air. So aerosol generation should be minimized. And the key point is preventing standing water. We love using water in sanitation, but the less water you use, actually, the better it is, for the simple reason, if you've got standing water, you might as well be growing biofilms there all the time. And in the egg industry, obviously, condensation, I don't have to tell you all about condensation being very significant. That's when you get the molds established on eggs, and that's where you get the problems. And another sort of thing that's missed a lot in the industry is about using the right sanitizer. So A lot of us in the industry have a certain sanitizer company you're with. I won't say what name because I'll probably get sued, but the reality is they're there to sell sanitizers. Some are helpful. You know, they'll sell you the right sanitizer for the right purpose, but you've got to appreciate if you've got mold infestation, you have to step up the sanitizer. It has to be different from the general sanitizer. And one of the key things is that if you do write plans, to follow them through, because often enough we get these paper exercises where people write things down and the person actually doing it's never even seen a document before. So that's important. You've got to always continue about improvement. Now, another sort of feature I find when you go to industry is this differentiation between clean and sanitized. I'm pretty sure most of you know the difference. When somebody says clean, obviously it's just visibly clean, but sanitized mean that you've decreased the number. Obviously sterilized is totally different. That's where there's nothing left at all. But, and in terms of contamination, we talk about biological hazards, you know, the pathogens, but you've got to remember also there's chemical hazards, and sometimes sanitized and chemical hazards go together, as we'll talk about in a little bit. So what I'm saying in the long term, which I think everyone knows already, is that sanitation is only one part of the puzzle. It can't be a cure-all. It's not a magic bullet, but if you've got everything in place, and sanitation is a very good supplementary tool to get that. So, as I mentioned to you, you can't sanitize a place which isn't sanitary. And when we talk about sanitary, we mean about not prone to cross-contamination. So your airflows must be good. Your sort of traffic from low risk to high risk areas should be restricted and separated. And so you can't sanitize a poor facility. And it reminds me of a project we had a few years ago in a restaurant in Toronto, who basically everything was falling apart, but he was really proud of the fact he had this really expensive sanitizer he bought, so it'll cure everything, which it didn't, obviously. But what I'm saying is that you've got to have good sanitary facilities with good manufacturing practice. So again, you know, I think everyone does this. When you look at facilities, you don't just look in the facility, you look surrounding the facility. I was over in Vancouver a month or so ago, and this public health inspector was telling me about this one facility there that she found 36 rat nests. I didn't know rats made nests, to be honest, but she told me it was 36 under this bush, because obviously they hadn't done it, and I wonder why they were getting a rodent infestation. So it's not just within the facility, it's around the facility as well, and product flows and air risk management or airflow management is key, along with decontamination of air, you know, because a lot of people, a lot of facilities don't appreciate that you have to have controlled airflow. It's not just good enough to put it through a filter and hope for the best. You've got to have this sort of high risk consideration that your high risk areas should get the freshest air and the low risk areas not so good. And you've got to have this sort of ability to sanitize. So a lot of facilities I visit, for example, old facilities, kind of expanded. Well, they haven't expanded room, they've expanded equipment. And so it's all close together. There's no way they're going to clean that. And sure enough, they don't clean it anyway. So good lighting, be able to disassemble, all these things are good to do. And the freestanding water, I can't emphasize that enough, is that you've got to minimize it, and you've got to construct it well. So this is an example about physical separation. Obviously, it's good enough to put a yellow line. I've seen that too often. We need that physical separation to reduce the transfer of contamination. You've got to contain it within a certain area. And the interesting thing about false ceilings, people are debating about this. Obviously, the bad thing about having false ceilings is you might also have an incubator up in the loft with all the molds growing and things like that. But after saying that, if you don't have a false ceiling, then obviously you're going to have a lot of areas where niches come. You're not going to be able to sanitize those easily. So the watchword is if you do have false ceilings, at least don't make them just tiles like you would have back home or something like that, or in the office. You have them so they're impermeable and plastic and cleanable.
Yeah.
And with the drains then, that's another issue, is that you can't have standing water for the simple reason you might as well start producing biofilms, and when you start washing things down, those biofilms get released into the air. And obviously with standing water, your humidity control goes all over the shop and you get sweating of your eggs, which is never a good thing. So another question that's always asked sometimes is the frequency of sanitation. And the important thing is that you've got to have a sanitation schedule. This sanitation schedule means that each part of the plant at some point gets cleaned and sampled. So it's obvious that those high-risk areas should get sanitized more frequently than the low-risk areas. And even though ideally you would want to do a sanitation very frequently, the reality is it's usually haven't got the time or the manpower, womanpower or resources. So you have to schedule it and keep to the schedule because it's so easy to forget things. So things like trays, for example, that's an obvious one to do, but transfer rooms to actually after each transfer. But the key thing is, even though you've got the schedule, you have to look at what the trend analysis, and we'll talk about trend analysis and sampling, what that's telling you, because you can go to a schedule, but if things are going wrong, you want to act there, and trend analysis enables you to do that. So what I'll do now is go through the quality management program, which is operates here in Canada. In the US, we've got other sanitation procedures and that, and abroad we've got even different ones, but they all mean the same thing. And what it means is to document things, to have standards and to document those standards and monitoring. So this is a QMP program which we operate in Canada in the CFIA, and amongst those is a prerequisite program. So the HACCP and things like that is one thing, but what we're interested in today is the prerequisites. And anyone in the industry knows about prerequisites. It's a lot of pain to do, it's painful, it takes a long time. But part of the prerequisite program, other than traceability and good manufacturing practices and construction of equipment and facilities, is the sanitation and personal hygiene, which is we take a lot of note of, isn't it? So the key thing about the documentation of sanitation is the standard sanitation operating procedure, which is popular in the US. We just call it SOPs up here. But SSOPs, I think, is a very good term for it, because what this does is give you a means of documenting what you do, who is responsible. So when things go wrong, you know who to go and see. And the key thing about it, you've got to say in detail what's been cleaned, how it's been cleaned, how frequently, and you justify that. So it's good to have a template and document everything from how to order a sanitizer to how to dismantle a hatchery or incubator, and how you're going to monitor it. How are you going to, when we say monitoring, how do we know you've done it correctly? So you've got to think about monitoring procedures and things like that. And as I say to you, your backstop is always your documentation. So you have to keep it in some sort of management system. And they allow computers now. They used to have to have hard sort of copies which filled briefcases and, well, not briefcases, the loads of filing cabinets and things like that. But and in terms of maintaining records, usually 6 months is sufficient. Obviously longer is good, but at least 6 months. So in terms of what you need to add in this SSOP then is you've got to, as I say, look at who's responsible and have they been trained to actually do this procedure, which sounds strange, but a lot of the times in sanitation, it literally is somebody learning from somebody else without having a sort of rigid training regime. It's just saying we do this and this is how we cut corners and things like that. And so you certainly have to have the training documented on what it was. And a lot with that is that you've got to think about when you're sanitizing, how you're protecting the environment, because not a lot of people think about this. When I go to industry, I want to say to them, saying, well, you're putting down heavy sanitizer like a peroxyacetic acid, or even things like chlorine dioxide, and you say how you're protecting your sort of food sources and should it leave taints. And so what you have to think about is sanitizers as both for health, which is microbial activation, but also a chemical contaminant. So you've got to think, well, when we do this sanitation, your feed, your water is not going to be tainted by it. And as I say, you've just got to justify as well about using the right detergent, as we'll talk about in a little bit, and the right sanitizer. And the frequency, as I said, you keep to a schedule and act when you need to act. So in terms of how the sanitation is being performed, you have to really document what sort of sanitation you're doing. Clean in place, which I'll talk about, is one of the most favourite ones, and we'll talk about the limitation. I'll give you a horror story where it went wrong. And then we'll talk about clean out of place and things like that. But as I say, it's all down to record keeping on who's doing what, how it's been done, and making sure that it's all well documented in terms of what procedure you did, what sanitised and things like that, and corrective actions. So out of all of those, the most important part is the corrective action. So I've seen sanitation plants where they've had no corrective actions at all, say everything's worked perfectly. The first thing auditors do is put a suspicious eye, because nothing ever works as it should do. So what you do with corrective actions is that you ensure correction of non-compliances, the wrong sanitizer, the wrong concentration, maybe it's expired or something like that. But what it also does is learn from mistakes. So you can say, well, we didn't pass this test with our sort of machinery because we did dismantle it enough, or we did something wrong. So you can learn from that. So in terms of corrective actions, then, as I say, you've just got to be wary of how you improve the sanitation plan. But obviously, the other important thing is when somebody spilled a load of chlorine dioxide liquid on the floor, and you start to get chlorine dioxide gas, what do? You know, obviously run for the door, but watch your spill pits and things like that. Emergency response plan, I suppose the best term is. All right, so we've got our prelims done. So how do we actually perform sanitation? And I'm hoping that this is second knowledge to everyone, because it's very interesting, even now when I go to industry, where they kind of don't quite appreciate you've got to get rid of detergents and get rid of organics before you actually sanitize it. So we'll go through each one in turn. So the thing is that when I was a student, I used to work in a vegetable factory, and you used to give me a hose pipe, and you just used to chase pieces of cauliflower around the floor with your hose pipe as sanitation. But obviously, if I knew then what I know now, it would be very different. So the first thing you've got to do is dry clean, because not only because you reduce the water usage, you're reducing these aerosols. So if you can get most of the debris off the floor without having to use water, that's good. And you can use brushes or vacuums. And also what you've got to start doing is dismantling equipment. And we'll talk about CIP in a bit, where that didn't quite happen, what the sort of consequence of that. So definitely dismantling as much equipment as you can. You know, the most famous outbreak, which I'm digressing a bit, is in Maple Leaf in 2008, when they had this big listeria outbreak. And what they were doing is that they were ramping up production, but cutting back on the sanitation. And so the sanitation crew couldn't dismantle this slicer. And so it built up a biofilm. That biofilm contained listeria, and it caused 24 deaths and over 1,000 cases. But it just illustrates how it can happen if you don't dismantle it. And as I say, from day-to-day operation, you tend to focus on things, and things become a habit. So when we never took that piece of equipment apart, we don't have to do it now. So anyway, so once you've done the dry cleaning part of it, you can use the hot water, obviously, to dislodge sort of solids. And I know I keep going on about it too much, but it's all to do with moderate pressure. Too little, you're not going to have any effect. Too much, you're going to make aerosols. You're going to damage the equipment as well. So you just got to make sure that you're using moderate pressure to get the job done. And but it's not all just down to you know, depending on the hose, it's physical action as well. So then you come to detergents. So your detergents chosen, which I'll talk about in a bit, depending on the soil. But what some people don't appreciate is you've got to do it in a certain order to avoid making aerosols and contamination. So what you kind of should be doing is getting a foam, because it's got a contact, but cleaning the walls first, and then the floors, and then the equipment after that, you know, because you're trying to reduce the spread of contamination. So this is the time you'll clean the drains. You don't clean the drains after you've done the sanitation, as certain companies I could mention do. But what's a sort of fact that maybe people don't appreciate is that if you leave detergent on too long, it makes a dry film, and that dry film becomes a source of biofilms. It becomes a source for niches to develop. So longer isn't always better. So you just got to make sure that you have it for a lot of time, which is a benefit of the SOPs, isn't it? And so you can just, so you don't get a dry film, you get it as active as you need to. And there's nothing wrong, as I say, with manual cleaning. because reality is cleaning place and even hoses can only do so much. So sometimes you've got to get your brush. But as always, you use dedicated equipment brushes to that particular area. You don't start taking your brush next door to the high-risk areas, things like that. So depending on your kind of soils to expect, this tells you what detergent to have. As I said, you try to avoid making dust and you try to use vacuum where you can, low pressure hoses. And depending on the nature of the organics that I'll talk about a little bit, it depends what detergent you use. But always, you've got to use potable water. I was in another facility where they didn't treat the water and it was straight from the well. They're actually putting down more contamination than we're taking off. And it does happen like that. Mm-hmm. And another sort of common thing I'm seeing at the moment is people who are treating the water coming in, like municipal water, stripping out the chlorine and just holding it in tanks and pipe work for when it's needed. Again, that can actually start forming biofilms if you're not careful. So you just got to be very careful about your water quality. And as I mentioned, the consequence of failure to remove organics, and when I say organics, they also mean detergent, is that you'll get biofilms formed. You know, I could tell you a story about what bugs can grow detergent, but I think I've put too many people off already. So as I mentioned to you, you've got to use the right detergent. So for a general purpose, that's good for fats and oils and things like that. Alkaline is very good for protein. So say, for example, in the egg industry, I'm not sure how many egg breakings you get, but that protein really sticks to the surface, so you need an alkaline to remove that. You can get chlorinated alkalines to kind of disinfect and take off a protein layer as well. But if you've got scale, that's the acid, and obviously for a soak, rinse or washers, they're good for using enzymes. And enzymes, we use our low water cold detergents, don't we? They're the same enzyme, proteases, lipases, so very cheap these days. All right, so once you've done that, you do your post-rinse inspection. And again, you do the rinse in terms of going through the schedule. You don't do your floors twice in this one, but what you do is you do your walls and then your floor and your equipment. But the thing is, don't be ever tempted to start rinsing the floors again, because, as I say, you're going to generate a lot of aerosols which can spread contamination. And it's at this point where you look for get your black light or your flashlight to look for residues. There's no point in trying to sanitize something that's still got residues on. Mm-hmm. And this is very seldom missed for the simple reason people think that's just detergent, we'll get on with it. But it's this diligence at each stage which is important. And as always, keeping the water restricted. Aerosols are your bane. So if you keep it within a enclosed sort of area, then you're going to be good. So then it comes to the actual sanitation itself. So you took all the organics, you've rinsed off the detergent, and then you can choose the sanitizer. I'm going to include step 6, rinse, no rinse. There are advantages. So quaternary salts, for example, it's notoriously is a no rinse. When I say notorious, it's got the sort of advantage of having a no rinse status. So you can leave it on. But obviously, if you leave it on, there is that risk of subpopulations coming through, top taints and things like that. So to rinse or not rinse is a question, but I suggest to rinse. And we'll talk about long-term protection as we go along. Now, as I mentioned to you, you get different applications about sanitizers, cleaning in place and fumigation and foaming. And with cleaning in place, what can happen, you've disassembled your machinery, you've done your detergent, washing, your rinsing, you put the machine back together again. So that's a hybrid approach. But I've seen some companies actually just use CIP. So I'm not too au fait with incubators, but I assume they're cleaning place.
Yes.
Now, the thing about cleaning place is that it's fine, but if you get niches that aren't contacted, then it gets a bit of an issue. And there was a company, as I said, that used clean place all the time. This was a juice company. And they used it endlessly. And what happened is they got a buildup of organics within the actual pipework. And so what was happening, they got biofilms produced, and they were really amazed when I told them to disassemble the pipework, and they found this really big biofilm on the actual gasket. But what it illustrates, CIP is good, but there again, you've just got to appreciate that if you don't get those zones, it's not going to be so good. So clean place is good, quick, but it has its limitations. So obviously fumigation is a preferred approach. It does have its hazards, vis-a-vis that you can gas yourself very easily. And formaldehyde, which I don't know if it's used a lot in the industry now. I know that people are trying to sort of get it out of the system because of the toxicity and byproducts. You know better than me about that. But it is a good way to actually spread the sanitizer to achieve what you need to achieve. And there's different kinds of variations in fumigation now. Chlorine dioxide gas, if you think back to 2001 with the anthrax letters, was put in the post office, and I think actually killed somebody in the post office with that. The only way they could disinfect it is using chlorine dioxide. Very toxic gas, very caustic gas. So it's very effective, but you've got to be careful of it. Things like peroxyacetic acid being used, ozone, hydrogen peroxide vapors becoming popular. But again, very corrosive, and efficacy is questionable sometimes. But the one that I see a lot of is ozone. And ozone's good, it's antimicrobial, but the trouble is, very highly corrosive. If you want to get through your cooling coils, just put ozone in the atmosphere. And the thing is, it's dependent on the relative humidity, which is sometimes missed. So if you put ozone to a dry atmosphere, it's not going to work at all. So you need at least 85%. It's very expensive, and you've just got to use it with wariness in terms of containing it, rather than letting it fill a whole room. But lots of people selling it. But as I mentioned, chlorine dioxide is a gas of preference, but it's very caustic. It certainly kills everything. It's very expensive, but as I say, very hazardous to handle, which is always a bad thing, isn't it? Now, one thing that's coming up, which has come and gone, and is kind of coming back again, is electrolyzed water. So if you work on the farm, they love electrolyzed water. You give it to breeding flocks and animal flocks, they say a very positive benefit to it. And so basically, electrolyzed water, then it's this anodic fraction of cathodic. The cathodic is sodium hydroxide. The acidic is the hypochlorite, but it's very acidic. It's not the stuff we buy at or shop, should we say. And so I've seen very good systems where they fog this into the air, and it's proven very effective in odor abatement, and also very antimicrobial. Now, some of the sort of new things, or lab-based things I call them, is QAS, which I've never thought about as a fumigant, but apparently you can buy it as a fumigant. Some of the essential oils I can never, ever see being practical. It makes it smell nice, though, wouldn't it?
It has been tried, and the one hatchery I know that tried it, all their staff got sick from the stink in the facility, so... essential oils, it's something that we've heard a little bit about here and there. I do know one customer that tried it, but it was not a good day, and took them quite a while to kind of get that scent out of their hatchery.
I bet, because it's potent. But you'll find that, I think when people talk about essential oils, it's this nice romantic vision, but some of these are really toxic, and people who drink these things need to, I don't know. But, no, essential oils is a natural thing. It was always by the by. But one that's an interesting one, which was actually developed by the US Homeland Defense, was this one called dehydrated hydrogen peroxide, or ozone, which is basically in the words for free radicals. But they were actually using it to disinfect facilities with anthrax. And they gave me a good story, but I've never seen it actually in action. But there's a company out there, Sanitation, which actually do... I think they do still sell it, but it's an interesting sort of variation on the theme.
Yeah, there's some research out of University of Georgia right now. One of the professors there, I forget his name, unfortunately, has been working on this, and we are hearing a lot more about the dry or the dehydrated hydrogen peroxide as a potential for the industry. So.
Yeah, basically it's just a marketing gimmick. It's essentially free radicals and if you don't get the relative humidity, it's not going to be effective. I did tell them that, but yeah, you're just going to be wary about these new technologies. But if you apply them in the right position at the right time, under the right conditions, you're good. So I won't go through all these because I think most of you know them. And the choice of sanitizers, as I said, depends on how bad things are. you've got to get the right sanitizer for the right pathogen target, and it's good to rotate, which we'll talk about. So there's no preference of one to another. Containing ammonium salts, obviously, that's one aspect, and you get the residue. Hypochlorite's cheap. It is very fragile, though it gets sequestered, and you get these byproducts formed. Hydrogen peroxide, I've seen used a lot. It's, again, expensive, corrosive. Zircon seems to be around for years. I remember using Zircon back in my day. Very effective. And but the aldehydes, they're kind of trying to be phased out, I think, most of the time. But the thing about these sanitizers, what you've got to be careful of is that they don't damage. So the temptation is to use very high concentration of sanitizer, and that causes damage, which obviously leads to biofilms. And once biofilms set in, you can talk to people about, oh yes, my sanitizer takes out biofilms. Well, I haven't seen one yet. So, people claim a lot, but if you actually walk the walk, it's not a thing, isn't it? At all. So, as I mentioned to you, when you're finding an issue, you've got to choose the right sanitizer. And obviously, different microbes have different resistances. Viruses, for example, can be pretty tough, as anyone who's had an outbreak of avian influenza would testify. But you choose the right sanitizer for the right purpose and make sure it's being validated at that concentration to tackle the pathogen of interest. Now, dry sanitation is probably alien to a lot of people in terms of, well, we just use water all the time. But there's very big benefits of actually going dry. Certainly reducing the water usage is one. Obviously, you're not going to splash everything around. And in the dry ingredients, feed mills, obviously dry sanitation is key. So not suggesting that you actually switch to a dry sanitation, but at least it's good to try and incorporate in order to reduce water usage, because water in the end can actually be the biggest sort of villain of the piece. So another sort of part some people do is in-process sanitation. So the thing about sanitation in the food industry is that you sanitize a line, and about 30 minutes into processing, it's all contaminated again, and you might as well not have bothered. And so in-process sanitation, using things like ozone, electrolyzed water is another good one that can be used there, an ozonated water, is very good because you can kind of keep contamination at bay. Whereas if you just wait for post-process, and say most of your product's gone through, you accumulate contamination. And so it's the kind of thing that's saying, well, rather than try and depend on one big event, just try to keep the contamination down as it is. And there's other things you can do as well. Now, one of the big questions I get asked, amongst others, is about sanitation rotation. So sanitizer rotation, you go to anyone, especially the sort of distributors of sanitizers, say, oh yes, you've got to sanitize, you rotate your sanitizers, and I just happen to have this sort of sanitizer you could rotate it with. The reality is there's no real evidence that it actually does anything. The old theory is that, well, if you have only one sanitizer, you build up resistant populations, and those populations become endemic, resistant, and things like that. But yes, you can do that in the lab, but when in reality, you've never seen it. But typically what you'll do to rotate sanitizers, if you're doing a sort of superficial clean versus a deep clean, obviously you've got time, chlorinated foams are going to be better than saying just putting some hypochlorite or things like that. So you tend to do that, or when you get an outbreak of mold. So if you've got a mold and it's growing on your wall, you don't just use the same sanitizer because you know that's not going to be effective. So you change it up that way. And when you're remediating after an outbreak, so your rotation of the sanitizer doesn't have to occur, but if you do it, then you do it for the right reason. But don't expect your same sanitizer to keep working if you've got a problem. It just illustrates it didn't quite work that way. Now, as I mentioned to you, one of the big advances in the industry these days is antimicrobial coatings. There's probably nobody out there at the moment who actually uses them, but it's one of the biggest sort of markets people suggest is going to happen. So typically what happens, isn't it? You do your sanitation, 30 minutes into processing, it's all, might as well not have bothered. But what happens if we could have this protective effect all the time? And this is where antimicrobial coatings have come to the fore. So you get different types. You can get the anti-adhesive. So you might have seen these stories on the news about shark skin and fish scale skin. They're famous because the architecture of the skin prevents microbials to bind. So you don't see many sharps with biofilms on, I suppose. But the reality is you can engineer those surfaces now, and you can actually buy them to do that. Ones we're probably more likely to find is these release ones. So when we're releasing, these are the sort of silver and copper, which are very popular. And so they release the antimicrobial, like contamination salts do. Some tag them in, and some use titanium dioxide when it's illuminated with UVA, produces free radicals. So these protective coatings, even though you probably won't be able to, not thinking about them at the moment, very good for places that you can't reach. So in ventilation shafts, in girders, usually applied as a paint, some of them, and they're very protective. So you can think about those if you think about changing. Now, foot baths, I put a special note here because every time I've been to a facility I've seen, they've varied. The worst I've seen was a tea towel on the floor soaked in bleach, which it was a very colourful tea towel. But then I've seen where they've just put a bit of foam on and just for your foam. And I've seen big foot baths which looked a bit murky. And obviously you get the Rolls Royce, which is the brushes and things like that. But it's no big sort of exaggeration to say our footwear, we take a lot of contamination around with us. I could tell you about if you just went to sample your boots today, you probably could find some very exotic pathogens there. And obviously we trap them into our homes, but you can imagine traipsing them into a facility and then going to another facility to trape them in there. So foot baths, as I say, you've just got to, I think, are much more important than people think they are. And with drains, the thing with drains is that people think they should be sterile. They're never going to be sterile, isn't it? It's, I was talking to somebody who put really strong sanitizer down, and they're always amazed saying, well, put it down 1 week and a few days later things grow back and you wonder why. But what's the big promising sort of feature or advance is using what we call these probiotic drain cleaners. And when we say probiotic, we don't mean we go on a certain mail order site and just order something for $10. These are specialized bacteria which have been adapted. Well, the control Listeria in particular, but I've seen bacillus ones which have got broader action. So these kinds of a probiotic for your drain to stop pathogens becoming established. And people use phages, but too expensive and not that effective. So probiotics, so rather than try and go nuke everything, try and get the population you want there. All right, so to finish off, I guess, we're nearly there at the end there, is to clean eggs. Now, cleaning eggs is a vital part because obviously 80% of the contamination coming into facilities is on eggs. And you can use alkali. Obviously, you've got to be aware that you've got a living creature in the middle of it. So you can use alkali, chlorinate hydroxides. And there's not much else you can do. You've just got to use warm temperatures to stop the ingress of contamination into the eggs. And what we've been working on is something called an advanced oxidative process, which could be an alternative to these things because it's a very gentle process, but very good at sanitizing surfaces. So I won't go too much into it, but here's a digression, is that we developed these systems admittedly for fresh produce, but you can see the egg application where it uses a combination of UV, peroxide, and ozone to make a cloud of antimicrobials, a bit like a dehydrated ozone and dehydrated hydrogen peroxide. And we were in California last week to look at the really big unit. This one can do 40,000 lemons an hour, so it's very impressive. But again, it's thinking outside the box, thinking what we could do differently. So to finish off, we'll be talking about the monitoring. So when we talk about monitoring program, it's very vital in sanitation for the reasons I've talked about before, in that if you don't monitor it, you can't confirm it's happened, which means basically it never did happen. So when you're doing a sanitation program, you need some monitoring procedures. And when you talk about monitoring, everyone says, it's microbial testing, isn't it? That's a very small part of it. The main part is making sure you've got the right sanitizer, the right concentration, the right contact time. So a lot of these monitoring is down to the person. So you've got to trust the person to tick the box and say, yes, it was this time and this sanitizer. When the microbial testing does come in is through the verification, i.e. your sanitation plan is effective. So monitoring not only gives you that due diligence, but it also gives you that culture. If someone has to tick a box, you'd be amazed how diligent they are doing that. But if you say, well, just tell me when you finished, you say, well, I might do, I might not. So it's very good culture to build up a positive culture, things like that. So as I mentioned, for monitoring, you tend to make more forms, which is the watchword, isn't it? And you say who's done it, how they've done it, and the corrective actions as we talked about. So in terms of monitoring, obviously, if you have to rely on people's honesty, they always let you down. So you've got to have some kind of measuring, measuring the actual sanitizer, measuring even the detergent, things like that, and making sure they use the right amount, to measured amount, rather than using too much or too little. People always use too much, and that causes corrosion, doesn't it? And when it comes to actual visual inspection, you can do visual inspection with your lights, but some people like the ATP meter. I don't know how frequently ATP meters are used in the hatchery industry, but they're very beneficial in terms of the food processing, because it gives you an instant reading about how good your sanitation was. So you can use an ATP meter to say, oh yes, you're doing a good job or not so good. But in terms of verification testing, we'll only do verification testing, basically just to verify that your sanitation is good. You don't need to do it too frequently, but you just do it. You're not there to catch people out in terms of saying they've done poor sanitation. You're just verifying that it's effective. And you can use plate counts and swab counts and sticky tape for that, just to take samples off a surface and then take them to the lab to analyze. But then comes the question, say, well, what do we analyze? And in the egg hatchery business, obviously, you're really interested in things like Pseudomonas, E. coli, Aspergillus, things like that. So they would be your primary targets. We also get indicators. So Enterobacteriaceae is a very good indicator, because the thing is that you want to get a number from these counts. So it's no good just saying absence and being happy with life and saying, well, yes, it's good, isn't it? You want to get some counts, be it total aerobic count or be it Enterobacteriaceae count, because that enables you to do trend analysis. Have a number you can say, are we getting better or worse? If you just do pathogen testing specifically, you just get a lot of plus and minuses that mean nothing. And that was another thing that happened in maple leaf. It just didn't do the dots up. So depending on what indicators you're looking for, it really depends on what your concern is. But it's always good to have, again, counts with either total aerobic count or Enterobacteriaceae count, so you can get a trend analysis. And another important thing is the air quality, which I'm sure you heard of. So with air quality, there's a lot of good samplers there you can buy fairly cheaply. And people take a sample, but then they look at what's on the plate. It's usually a load of different bowls and things, and they say, well, what's a good number? And the thing is, there's no such thing as a good number. What it really is what's on there that's more important than what isn't. So, for example, if you are looking at the air and you find Aspergillus in the air, that's going to be much more significant than another mold, isn't it? Like penicillium or vice versa. So what you tend to do is you make yourself a baseline and you do trend analysis. And even if you don't look at specific counts, you can do air quality monitoring. And there's a device out there which detects volatiles, which gives you an indication saying something's not quite right in the air. So the air, to me, is one of the most critical things, be it in a hatchery or be it in a food processing plant. People don't quite appreciate the seriousness of it. And as I say, people always ask me, what is a good number? And I say there isn't such thing as good numbers. You can have guidelines, a clean surface is 10 CFU or something like that. But it's all down to trend analysis at the end of the day. And so when you're trying to establish a baseline, what you have to do is for your facility, because each facility is different with different capabilities, is to sanitize it diligently and then look at counts, be it ATP counts or bacterial counts, contact plate counts, and that becomes your baseline. And what you want to do then is to obviously drive the baseline down from those counts. And you do that by revising sanitation and things like that. And in terms of frequency, as we talked about, you tend to have a schedule. But when things start going wrong in your trend analysis, i.e. the counts start going up, that's the time to start sampling more frequently. But you don't just sample randomly. You've got to be very strategic in it in terms of zone sampling, which I'm sure you're all aware and know of. So, as I mentioned to you, microbial counts is just one aspect of verifying your sanitation plan, which you can do internally, or you get your auditors to do it. But you're basically reviewing the corrective actions, SOPs, and even looking at the sanitation crew in action. Is there something they could be doing wrong? Because you get blind to certain things, and you do things every day. And it's good to have someone come in and say, well, you could do these things differently, things like that. And always have this sort of target. So you're never going to be perfect. It's not going to be a surgery. But if you have a target and you set out the different areas to get achievable targets, and that's all well and good. So it's all a bit subjective, but I think you get to the point. People always got something to strive for. They don't, especially in sanitation crews, which were undervalued previously, but sanitation crews now are the most important people in the facility. They're the ones that's going to save you. So in terms of trend analysis, as we said, it's usually a rolling window. So we take samples periodically, once a month, once a week, and we see where the counts are going. Is it down to sample error, because we've got the new technician sampling, or is it ramping up because we've got a biofilm? Or did we change something? Did we change our sanitizer? Suddenly the counts have gone up. Trend analysis enables you to determine that. Just taking sporadic samples will not. And to finally finish, one of the another big issue, a lot of big issues, isn't there? But this big issue is root cause analysis. So I was at a facility the other week there who got a Listeria positive. And their first action was to actually drench the place in sanitizer. In actual fact, what they should be doing is root cause analysis. You've got to get to the niche of the problem. If you don't, it's going to reoccur. But there's different ways to do root cause analysis, which I'm sure you're all aware of. The 5 whys, which is Japanese sort of philosophy, where you just basically ask the question, why did this happen? How could it happen? And you go through different scenarios in order to find out what it could be. And just to illustrate that, this is one that's totally not relevant to anybody here, but about a meat delivery at above 4 degrees C. Well, why was it the meat at that temperature? And you go through a series of questions in order to derive what the answer is. And if you can't find the answer, you go again until you do. So a very simple way of doing it, but very effective. Always find the root cause of any deviation. You can use fishbone diagrams, which are a bit more complex. And with a fishbone diagram, it's basically a book of all the things that could go wrong and scenarios, and you always add to them. So basically, it's separating out between staff, equipment, and things like that. And you're deriving the scenario, you're cutting the scenarios out until you find the root cause so you can solve it then. So in conclusion then, I think we all know sanitation is important, but the important thing is that it has to be documented, but it mustn't become a sort of focus on documentation. Basically these are real actions, these are real practices, but you've got to be able to validate and verify it, and always look for the next big thing in sanitizers. We basically limit ourselves to what we have these days, but there's always new things coming up. And when you do get issues, you've got to do the root cause analysis, find out the source, and then figure out how you're going to revise your sanitation plan thereafter. That's good. So, I'll obviously answer any questions some people might have.
Sure. And we did have some questions emailed in advance, so I'll just pull those up here. Let me take down the presentation. So anyone can enter their questions in the Q&A panel. That is found in the upper left corner of your screen. And you can just type in your question there and we will answer it on air for you. Let's see. One of the first questions we have is a common one, which is about the incoming eggs. They're generally, if they're not floor eggs, they're clean. And just, as a general recommendation, and you guys have all heard this from all kinds of consultants from all kinds of companies, that floor eggs, even cleaned, are never going to be as clean as your nest eggs when they've been collected quickly. So always be careful with your floor eggs. As far as our recommendation there, we follow the lead of Aviagen, of Cobb, of those guys. And yeah, we do agree that, cleaning floor eggs, while it can be done, it's not ideal because those eggs are never going to be quite as clean. I have a question. Have you had any experience with the Clarion sanitation program? I'm actually not familiar with that at all. Are you? It's Klarion.
Clarion, never heard of that. It sounds very familiar to one that I do know, which is based on pure alkali, but I don't think it's that one at all. No, the thing is, there are different sanitation programs out there, but what you've got to be very wary of is that these sanitation programs are usually based on sort of theoretical principle, which is very different from reality. So certainly with sanitation, it's not a magic box, everyone knows what to do. But as I said at the start, what I frequently find is people using sanitation to compensate for something else in terms of faulty equipment or bad design. So as long as it's effective, I think it's fine. But you always got to be wary about there's no sanitation plan. A bit like, I guess, when we take our protein shake, isn't it? Saying this is our diet and things like that. Weight loss, it makes us feel good, but you think, well, does it actually the right thing to do? But yeah, that's the answer for that, I think. Very interested to hear about that, see what it is.
Yeah, if you want to send us some info to webinars@jamesway.com, maybe the link or something like that, I'll take a look at it later today because I'm interested and I haven't heard about it and see what I can find out. Another question we have here is how can we control bacteria in the ventilation system, which is a really good question. The first answer is, of course, you guys have all heard this from me before, but reduce the length of duct in your facility so that you have less ducts to clean. Your ducts need to have cleanouts every 10 feet so that you can actually get in there and clean those ducts. But what else can they do to reduce growth or, hopefully not, but biofilm production in their ventilation and in their ducting?
And that is a very good point, because I've seen occasions where you do get all kinds of things going to ducts. And this is where the antimicrobial films come in. So I won't mention any makes or anything like that, but there's coatings you can get for inside ventilation units, which are fairly effective at reducing any sort of attachment of biofilm. I've seen systems where they actually obviously use the HEPA filters and things like that, which is fine. But certainly there's a lot of new devices coming up now or coatings that are feasible. But as you rightly said, shorter the better, isn't it? But certainly it's an important area because these sort of weak links that people don't appreciate.
And the problem there, especially it's been mentioned that, the hatchery that is in question is an older facility. Until you upgrade the equipment, take out those ducts, put in new clean stainless ducts, everything you're doing is going to be a Band-Aid. When you are putting in those ducts, rule of thumb is either not insulated, or if they're going to be insulated, it needs to be shrouded on both sides, completely impermeable so nothing gets in there and grows in that insulation. So that can be a problem. Now, what about UV lights? It kind of seems to be a trend at the HVAC shows. Every year there are more UV light companies there with equipment that you can pop in your HVAC. What do you think of those systems?
Oh, no, I've seen some really good ones. My favourite one was this looked like a ray gun that you put into the HVAC. The reality is they haven't got the residence time. It's not UV isn't a magic wand. Now, where they are handy is that when you combine filtration with UV, because the trouble with filters is that they actually form a breeding ground, obviously, they get molded up and things like that. So it was a very good system where they had the capture on the filter, they've got the UV light, and it gives you that exposure time. But all these devices I've seen where you just literally put the UV into a vent and just whisk it past, I've never seen them being ever effective. There's no evidence out there that they actually do work. And there is that added feature about worker safety, because there was an occasion where people did put UVs in the vents, and lo and behold, someone got blinded by them when they looked up. But that's as I say, when you're working with UV, that's what you've got to be very cautious of.
And then we have another question. A customer who is looking at having both layer eggs and broiler eggs in the same facility, and what to do there. And we've also, had people who have had interest in having chicken and turkeys incubated in the same facility. The first thing there is separation. Ideally, those would be 2 hatcheries in 2 locations, considerably far enough away from each other, particularly if it's turkeys and chickens, because turkeys are a little more susceptible to diseases. But any other things you can suggest for someone who is building a combination facility?
Well, I must admit, I didn't know that about turkeys. You live and learn, isn't it? But it's like, the food industry in general. Anytime you start mixing things together, it's the time things start going horribly wrong, isn't it? So, but the reality is, I suppose, as long as you're given the same treatment, you should be good. And a lot of the sort of processes, like in the food industry, we look at is what we call kind of firewalls. When we say firewalls, we mean it separates one part from another in terms of decontamination. So in our area, in fresh produce, we try to separate the field from the processing plants. I guess in a lot of the egg industry as well, it's if you're having inputs, which obviously brings in the contamination, at least have treatments there where you could kind of set a baseline. But yeah, I agree with you. It's obvious that separation is always a key thing.
Yeah.
Because anytime you bring anything new in, it's always going to be an issue.
Yeah, and we do have one customer who does have a combination layer broiler hatchery. So we could possibly put this customer in contact with them to discuss what they're doing there. Because yeah, it is going to be, a bit of a challenge. And part of that is going to be making sure that the eggs coming in on both sides are coming from good, clean breeder sources. Because, we want to make sure that those layers stay strong for as long as they're needed. The only other question I see right now, so if anyone else has any additional questions, please drop them in as we close down here. But there's a question about fumigation, and I know Dr. Warriner is not very familiar with our fumigation procedures. It's sort of a 2-part question. The first part is fumigation still used in the US and Canada? And I can say that it definitely is. We are fumigating eggs at some facilities. We are fumigating also in the hatchers still. And then there are some sites, some of the more genetic sites that are fumigating all the material that comes in before it gets into the facility.
Are they all formaldehyde?
Not all they're not all formaldehyde. Formalin is being used. As some of you will know, we've talked about Biosentry 904 is used but can leave a bit of a sticky residue. When it's used, there's peroxide being used. There's actually quite a very wide list. Alcohol and ethyl alcohol has been tried by at least one customer that I know of. So as far as fumigation, still being done here. Not so much on the incoming eggs, because I think for the most part in the US and Canada, we're fairly strict on what's coming in from those breeder barns. But it is a very wide amount of chemicals that are used, and everyone is really looking to get formalin out of their hatcheries. It's a risk to our staff. OSHA is not keen on it. There's some research that suggests it's not the healthiest for the birds either, of course. So there always is that push to find the magic bullet that replaces formalin. And on that, I can say that I don't think anyone feels like they've really found it from a hatchery manager perspective. I'm sure there's some companies that will tell you they have, but I don't know if any hatchery manager that is completely satisfied with what they have. And then the second part of that question is whether fumigation is different for different types, strains, or eggs. And I don't actually know the answer to that. I'd assume just based on the list that I've been given that probably not. If you're using, if you're hatching turkeys, they're a little bit, more susceptible to things, a little bit more difficult to hatch than chickens. So you probably want to be pretty careful there. As far as other birds, or is it a cob versus an avian thing? The best thing really to do would be to ask your genetics company what it is they recommend, and if they have any recommendations. All of those genetics companies are really good at publishing papers on all different kinds of techniques in your hatchery, including microbial checking and eggshell temperatures, and I'm sure that there is some information on fumigation, so your consultants or sales reps can probably put you in contact with that.
Yeah, but I would always be suspicious of any sort of data you look at. It's always good to critically evaluate it, because never believe everything sight unseen.
Exactly.
Yeah.
All right. Well, I want to thank everyone for joining us, and especially thank Dr. Warriner for journeying down the highway to visit us today. So thank you for joining us.
Thank you for the invite.
As far as our January topic, we actually haven't set one yet. So I am, as usual, looking for your suggestions to webinars@jamesway.com. But look for the e-blast and the blast on the social media on that shortly, and we'll let you all know. And of course, IPPE is in February, so we hope to see you all there at our booth. And thank you for joining us. Have a good day, everyone.